Good morning, everyone. Welcome to Core Java. So we are in collection in Core Java. So in previous session, what we have seen, cursor of Java. So there are three type of cursor: enumeration, iterator, and list iterator. And we have seen the difference, okay, with the program also. Then we started set, okay. So what is set? It is a child interface of collection. If you want to represent a group of individual object as single entity, then where duplicates are not allowed and insertion order is preserved, then we should use set. We, according to our diagram, if you go to our previous diagram, if you see in this diagram, right? So what we need to understand, what we need to learn under set: interface has set, linked has set, sorted set, navigable set, tree set. All these things we need to see. Okay. So let's start with hash set. Come down. So what is hash set? Hash set is following one hash table. When we do internal, then you will see all these thing internal of hash map, hash table, array list, all these thing internal table. How this internal it is working. For now, we are just trying to understand the collections. Okay. It following hash table. Insertion order is not preserved. One second, one correction. Insertion order is not preserved. For set, insertion order is not preserved. Okay, not preserved. So insertion order is not preserved and it is based on hash code of object. Duplicates are not allowed. Okay. Now, we'll see some program. This is the program. Hash set. We have written one simple program, hash set, and we have checked. We try to add some data. Okay. Now let me run this program. What we have seen. See. Okay. So now, what we are trying to see is we try to add some data like string data, Amit. Similarly, we try to add some data SRK and add null. Now, if I will try to add some same kind of data SRK again, let me add here. So it will, let me run the program. Now it is giving false, right? So duplicates are not allowed. You don't get any error, but it will return false. Because already we added SRK, right? As a string. Now. So what are the constructors? Constructors. So already we know hash set, HS equal to new hash set. So new hash set. This is one constructor. This is one default constructor. Okay. Now copy this, paste here. So the next one is initial capacity with initial capacity. We can provide the initial capacity. When we create this hash set, okay, so default capacity is 16. Default capacity, default capacity is 16. I mean, it can hold 16 objects. Okay. Now, we can provide the initial capacity. This is one constructor. Okay. Now, after that, we can convert this hash set into collections. One collection into another collection. For array list, if I provide here, then it can be converted into equivalent hash set. Okay. Now, one more constructor is there. where we can provide initial capacity. Let me copy this. Initial capacity. Initial capacity with field ratio. Field ratio type is float. Field ratio. What does this mean? Save this. So default capacity is there, but the field ratio is 0.55, 0.75, and the field ratio is 0.75. So what does this mean by field ratio? What does this mean by field ratio? Field ratio means if 75% of capacity is filled, okay, a new hashed object will be created. For example, 0.75. If what is the capacity? For example, just think if the capacity is 10, what is 75%? Around there are 7 capacity, so around 7 to 8 when will the data will be filled, then what will happen? Automatically new object is going to create for hash set. This is what field capacity. Okay, field ratio. Field ratio. It means after filling 75% capacity, automatically a new hash set will be created. A new hash set will be created. Okay, and this is also called field ratio, load factor. Okay, now so float, the value is in decimal, that's why the ratio here the data type is float. So these are the constructor inside hash set. Okay, now the next collection is linked hash set. Linked linked hash linked hash set. Linked hash set. Okay, so it is same child class of hash set. It is a child class of hash set. Hash set. Try to understand. Collection child is whom? Set. Set is what? Interface, right? Set is what? Interface. Set is what? Interface. Set childs are hash set, hash set, and hash set and sorted set. Sorted set. Okay? But coming to hash set, so linked hash set belong to whom? Hash set. Linked hash set is a child of hash set. Okay? No. So it is a child class of hash set. So whatever the property we have discussed for hash set, these all will be applicable to whom? Linked hash set also. Okay? No. If you see, there is one word difference is there. What is that one word difference? Hash set. Here we added one word linked. Linked. Right? So for hash set, underlying this data structure is hash table. Okay. But for linked hash set, but for linked hash set, the underlying data structure is hash table and linked list. Linked list. So hash table is hash set is having hash table, but linked hash set is having linked list also. Okay. And because of this linked list, in this case, insertion order is preserved. Insertion order is preserved. People will ask you what is the difference between linked hash set and linked hash set. Then you have to think about this point. For hash set, what? The data structure is hash table. Let me copy this so that you can easily visualize this. Copy this, come here. Let me paste here. Now see, underlying data structure for hash set is hash table, but for linked hash set, it is hash set, hash table, and linked list. Okay? Insertion order is preserved because of this linked list. Okay, but if you see here, insertion order is not preserved. Okay, this is from version, which version? 1.2 version. This is from 1.2 version. 1.2 version. This is from 1.2 version. And this is from 1.4 version. 1.4 version. This is from 1.4 version. Okay. Now, now try to understand. Now try to understand. He will add some more data here. Try to observe guys output. Try to observe output. Huh? Let me add HRK. That is Ritik. And let me uncomment some line which is we don't require. Control D. Also. Let me print this Control X. Now observe carefully the output. Just I am doing one change only. One change only will make you understand the difference. What is the output? Null, HRK, Amit, SRK. But first we added Amit. His insertion order is preserved? No. I am converting hash set into linked hash set. Just adding one word. See, linked. I am adding one word linked, and here also one word linked. And just Control Shift O to get the import. Now observe the output. See, Amit, then SRK, then null, then HRK. Order is preserved now. Order is preserved, right? You understand the order? Only did what we did only. We just change, replace hash set with linked hash set. So then order is preserved, right? Okay, now. The next is sorted set. Sorted set. Hash set part is done. Sorted set is child of what? Set interface. So let me use sorted set. Sorted, sorted set, sorted set. Okay. So what is sorted set? It is, it is, it is child interface. It is child interface of set. It is child interface of set. Okay. So if we want to add duplicate, if you want to add duplicate of individual object, if you want to add, if you want to represent individual object without 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 duplicate without duplicate and all objects guys, For your information, I am adding string integer. You can add employee object, student object, some student object also, right? Then you can add something objects as well. Okay. It's all about your practice. So all objects inserted to some sorting, to some sorting order. Okay. When to use this? We want to add some objects without duplicate. Okay. And the objects are inserted in some sorting order. Then sorted name itself is saying sorting, right? What is mean by sorting? Alphabetical order, numerical order, right? This is called sorting. Okay. Now, the next point is so the sorting. What is you understand, right? What is the word sorting means? Alphabetical order, A, B, C, D. Reverse of A, B, C, D means in reverse alphabetical order. Numeric means ascending order or descending order, right? How you are clicking, how you are doing sorting. Sorting means you understand, right? Sort. So sorting means, okay. Now the sorting can be default. What is mean by default? Sorting order, default, natural sorting order, natural sorting order will be A, B, C, D, E, F, G, not in reverse. And in numbers 1, 2, 3, 4, 5, 6 in ascending order. Okay. So for default natural, the sorting order, the sorting can be default natural. Okay. Default natural sorting. Default natural sorting. For string, string is of what type, guys? English character, right? So it is alphabetical order. And for number, ascending order. Okay. That's why string sorting will be alphabetical order, ABCD, alphabetical order. And for numbers, for numbers, for numbers, for numbers, sorting will be ascending, not descending, natural ascending order. Okay. Now, there is also one concept related to sorting. Very important. People maybe ask you in interview, what is comparable and comparator? That you will see soon. As I'm telling you, we are discussing sorting. Comparison is there. Okay. Now, what are the methods available? What are the methods available? Methods available. First, the first method is there. So it will return first object. Okay. Now, let me remove this part of the code. Okay. Let me add some sorted sorted set ss equal to new sorted set. Objects created, control shift tool to get the import. Sorted. Oh, sorry. It is 1 second. My bad. My bad. 1.1 point. It is not a class, na. It is what? Interface. Remember. It is a interface. It is a child interface of set. Why I am creating the class. So what are the method available? Okay, what are the method available? Method available is first. We will understand what is the first. And then these methods are by default available to child classes. So what it will give, it will return. When I'm saying return, it will give output of first element. First element. This method, first method, inside which sorted set. Now, similarly, we have one more method, last method. So you understand by seeing the first one. First one is giving first element, so it will give last element. It will give last element. Okay. After object, we have head set. Okay. We will see these methods. More methods are there. You will see in our implementation class. So, guys, what is the child? What is the this set is sorted set. So their child is what? Tree set. Now come here in our diagram. Sorted set, navigable set, right? Tree set. Now we will see this all this thing. Okay. Come here. Come here. So now what is our child class of sorted set? First we will go with tree set. Let's say tree set. Important concepts. Tree set. Okay. Now underline, underline, underline data structure. Underline data structure is balanced tree. Balanced tree. Balanced tree. Insertion order is not preserved. Insertion order is not preserved. Preserved. Insertion order is not preserved. Okay. In this case, guys, you remember, right? I mentioned heterogeneous objects. Heterogeneous object is not allowed. Right? Heterogeneous object is not allowed. Very first time I explain you, when I explain in this diagram, maybe I have written or not. Let's see. In tree set and tree map, heterogeneous objects are not allowed. In all this collection, heterogeneous means two different type of objects, student object, employee object. So in any collection you can add, but whenever you see the word tree, whenever you are seeing the word tree, here tree set and here tree map, always remember for trees, whenever you are finding this word tree, so heterogeneous objects are not allowed. Okay? Remember this part. Whenever you are seeing this tree word, remember this part. Interview question. Okay? Insertion order is not preserved and heterogeneous objects are not allowed. Heterogeneous objects are not allowed. Okay? And if you try to add, we'll get exception. Okay? You will see that what kind of exception we'll get. Mostly this class cars exception we will receive. Duplicates are not allowed. Duplicates are not allowed. Duplicates are not allowed. Duplicates are not allowed. Null insertion is possible only once. Null insertion is possible only one time. Only one time. You can add only one time, not second time. Okay? Now try to observe. Let's have a program. One minute, guys. Now let's say reset. 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 TS equal to new reset. Reset. Control Shift O. Now object is created, right? Reset. These are the constructor. Okay. Then we have some more constructor. Let me add some constructor also. Then we will write the program. So this is one constructor. Okay. Then we have one more constructor where we can pass comparator. Comparator, which I was telling you, right? Comparator, comparable. So this concept we have to understand. Interview question related. Okay. Then we can have like Collection, we can pass collections. We can pass collections. We can pass collection. Okay. Then we can pass sorted set also. Sorted, sorted, sorted set. Yes. In this constructor, when you pass sorted set can be converted into tree set. If you pass collection, then that particular, for example, array list, linked list, any collection you will pass, that will be converted into tree set. Comparator object, when you are passing, it will be converted into tree set, right? So now, and you know, this is the default constructor. Now try to observe. Constructor. So these are constructors. Okay. Now let me create some program. So tree set ts equal to new tree set. Okay. Now let me add some value. ts dot add. Okay. Now let me copy something inside this. Let me add Amit. I am adding Amit. Let me copy this multiple time. Amit. Amit. Let me give small Amit, capital Amit. Now I am giving some number. Let me give some number Amit. Okay. Let me give SRK. Okay. Now I am giving some number. Let me use some number like this. Is it possible? Let's try. And let me add null also. ts dot add. How many times we can add null? One time only, right? Null. Can I print this? Let me print this. System dot out dot println and ts. Can we run this program? Now let's run the program. Run a Java application. Class cast exception. Class cast exception. Okay. One. Because of this line. Now let me run the program. Null pointer exception. Okay. Now Amit, SRK and Amit. Okay. Now. So when we are adding null, what we observe, what we are getting? See, one second. What we are getting? Null pointer exception. Let me run this program now with null. What we are getting? Null point exception. Null pointer exception. Okay. Now let me comment this line. Whatever string I am adding, I commented that. Now adding without this number only. Now, did you observe something? When I'm adding ts dot add 1 2 3, it's taking. Okay, it's taking. Okay, now. But when I'm commenting line number 13, ts dot add with srk, java.lang string cannot be converted to integer, right? Hope you are observing, right? But let me change the order. Let me change the order. Control X. Destruct. After this integer value, I am adding string. Now let's see what will happen. See, integer cannot be cast to string. This is the exception we are getting. Okay. Okay. But when I am adding this value, only integer, then it is taking, right? So this is what we need to understand while working with tree set. Okay. There is a chance of class cast exception because heterogeneous objects are not allowed. That is what I tried to say. String and number, both are two different type of data type. That's what class cast exception we are receiving. Okay? Now, Let me run this program now. Null pointer exception, right? Okay, let me run this. We are getting null pointer exception. Okay, for nulls. Okay. Now, null acceptance we have to discuss. This is tree set, right? Now, let me add some point for null acceptance. For empty tree set, empty tree set. First element null is possible, but after that, if we try to insert the null, then we will get null pointer exception. Then you will get null pointer exception. Next point. For non-empty tree set, if we try to add null, then we will get null pointer exception. In short, I am giving NPE. Okay? No. Right. Now, I'm just changing this program. Okay? This tree set object. Okay? Now try to observe. TS dot add I am doing. TS dot add I am doing. Okay? Something like this. This time I am doing what? String buffer. For example, there are some string buffer object is there. New string buffer. Try to observe. I am passing string buffer and string buffer is holding A. I am passing to whom? String buffer object. String buffer object is added to whom? Tree set object. Okay? This is string buffer object where I am giving this, and this string buffer object I am adding to whom? I am adding to whom? This is tree set. Okay? Now try to observe something we are going to change. Okay, now try to observe. TS dot same way. Let me add some copy this line. Try to observe. Now I am giving A, B, C, D. Try to observe A, B, C, D. And let me print this statement. System dot out dot println. What is the hash set? Tree set TS. Let me run this program. Cannot be cast to java.lang.comparable. Exception we are getting, right? What is the reason for this exception? Try to. For this exception, what is the reason? Now let me provide the information. So we have some sorting order, right? So we have to do homogeneous and comparable. This is the one requirement. If that is the object is not comparable, then what will happen? We are getting this exception. What is the exception? Again, read this. String buffer cannot be cast to java.lang.comparable. Tree set is comparable, na, but try to see. Let me copy this string buffer. Control Shift H. Let's check this string buffer. String buffer. Open this class. This class implements serializable char sequence. Is this class implement comparator or comparable? No. Control Shift H. Let me search tree set. Tree set. This is tree set. Open this. Open this class. If you see this, what is abstract class, navigable set, clonable. Okay? If you open this, this is something like given. Read this. Copy this. Control Shift H. Copy this. Control Shift H. Set. Control Shift H. Now let's set open set. Default natural sorting order. Then we should, then we should, then we should compulsory object should be homogeneous and comparable. So comparable is nothing but an interface. This is nothing but interface. Let me keep this in bracket, interface. ठीक है? So when we call the object is comparable, if that particular class which we are using that implements comparable interface, a class is called as comparable. Important guys, focus. A class called as comparable when, if it implements comparable interface. Comparable. If this interface is there, any class is implementing this class, this interface comparable, then that particular class is called as comparable. ठीक है? Now, all wrapper class implements comparable. Let's see. Control Shift H, integer. Open this. See, integer implements comparable. It is a wrapper class, right? But string buffer does not implement comparable. Do you observe anywhere? String buffer implement comparable? No, right? String buffer implement, it does not implement comparable. So, but string buffer does not implement comparable interface. ठीक है? That is the reason we are getting what exception in our class when we run, because we are trying to add where in tree set object, but this string buffer when we are trying to add, then what is it we are getting? We are getting some result as exception. See, string buffer cannot be cast to comparable object. Okay. Now the next is comparable and comparator interface. Interview question people will ask you in this interview. What is comparable and comparator? Comparable interface and comparator interface. Once we understand this concept, then we will understand this comparison. Okay. Now, first we will go with comparable. Comparable. So comparable interface present in java.lang package. Java.lang package, and it contain only one method. It contains only one method. But comparator contain two methods. Okay. It comparable contain only one method. What is the name of the method? The name of the method is compare to. Compare to is the method name. Let me add the syntax. Public int compare to, and it will take some object. Obj. Now, what is happening with compare to and comparable? Try to observe in very one or two points. Let's say you are comparing two objects. There are two objects. One is object one, and you are having compare two method. Compare two method, and you are passing object two. You are passing. What will happen when you are comparing these two objects? Something we need to understand. Then we will observe. It returns what it is. What is the return type? Int, right? Positive number, negative number. So when we are comparing some two objects, object one and object two, using this method, then what will happen? If it return negative number, if and only if object one has come before object two. Okay. Try to observe one program, then you will understand. Let me remove this everything from here. Let me delete this line. Let me copy this line. Paste here. Okay. Now let me add some string. I am adding K, some A, B, C, D, E, F, G. I am adding some A. Now let me remove this program. Next two lines. Okay. Now what is happening? Try to observe. Let me run this program. See A and K, right? So what is happening? It is whenever we are passing some string character. So it is behaving default natural sorting order. Na? Okay. Then what will happen? JVM will use compare to method. For example, it will compare. You added what? We added K. In a ABCD, when we go for ABCD, what will come first? A, right? So that's why it is coming A. But how it is coming? It is comparing. Let me add some more character here. Then you will ts dot add. See, I am adding Z. Z is last and A is first and K is some in middle order. Let me run this program now. Run a Java application. Now, what is happening in the background? Try to observe. First, we added K. What we added? We added what? K. We added K. Right? Then what is happened? Next character, what we added? Z. Right? Next character, we added Z. So Z and K is compare. Z and K is compare. So Z is compared to K in this way. Try to observe. Then what will happen? Z will be compared. Z is string, right? So Z is compared. Z is compared by JVM using compare to method. Compare to method. And what will be passed here? K. So what it will return? It will return some positive number. It will return some positive number. Similarly, when next line, when we are added Z and A, then what happen? A is compared to same way. A is compared to what? A is compared by JVM using compare to method. With respect to whom? With respect to K. With respect to K. Then what will happen? It will give negative number. Okay. So this is how, if negative number is there, it will keep that in first position, and positive number, it will keep that in next position. So when A is compared to K, so it is giving negative. So A will be placed before K. And similarly, if Z is compared to K, Z by comparing by compare to method, what is the output we are getting by compare to method? Some positive number. So Z will be placed after K. So that's what how it is maintaining this order of sorting. Even though we are adding at any place K, Z, A, anything in different order, but it is printing what? In this order, alphabetical order, A, K, and Z. We can customize our orders. See, this is default, sir. This is default. I don't want default. You don't want default. If you want uh, our own sorting order, okay, then we have comparator interface. We have comparator interface. Okay. Now try to observe. So comparable is providing what? Default sorting order. Default sorting order. I want to customize it. What is mean by customize? You have some bike. You want color change. You want some handle change. You want different tire. You modify it na, by your own. You go to mechanic and you modify it. So comparable is following what? Natural sorting order. Right? But comparator has two methods. The two methods are compare and equals method. So using those two methods, we can customize our sorting order. Okay, 1 minute. So guys, we will see this comparable and comparator in detail tomorrow. We will close this comparator tomorrow, and then we will start map. Okay. So map we will start, and then we will see hash map, weak hash map, identity hash map, sorted map. Okay. Hash table, linked hash map, navigable map, tree map, all this in map. Okay. So first we will see this comparable comparator and detail program, so that you will understand how the behavior of these two interfaces. Okay, then we will start map also. Okay, I'm stopping my screen share. I'm stopping the recording.